Hi, my name is Dr. Tishan. In this video, we're going to take a look at the second fundamental theorem of calculus. In this second fundamental theorem, we're going to take a look when we have an integral expression that has variable bounds, and then we're going to take the derivative of our integral expression, see how that works. And then I'm going to show you a shortcut method that you can use to achieve the same goal. This shortcut method comes in handy when you have an integral expression that you can't integrate by hand. So let's go ahead and use this example to start with, because we're going to just go step by step. We're going to work from the inside to the outside. We're going to show all the work. We're going to see what the answer is that we get, and then we'll take a look at the shortcut. So we're going to find the derivative of the integral. This integral, lower bound is 3, upper bound is 5x of 2t dt. All right, so let's go ahead and start by, we're going to work from the inside to the out, so we're going to start by integrating. Okay, so we have the derivative, we'll take care of the derivative at the end, okay? All right, but we're gonna do the integration. When you integrate 2t to the first power, you're gonna get 2t squared over 2, which means you're gonna just get t squared when you do the integration. We're gonna evaluate this from 3 to 5x. All right, so integrate 2t, you have t squared. So we're working from the inside to the outside. We're going to work step 1. We're going to go ahead and we're going to do the integration first. All right, next let's go ahead and use the fundamental theorem of calculus to evaluate. So I'm just going to carry this derivative expression down. We'll do the derivative expression at the end. Fundamental theorem of calculus, okay, so the fundamental theorem is when you're going to take this expression, plug in the upper bound. When we plug in the upper bound for t, we're going to have 5x, and we're going to square that quantity. All right, and then subtract from that, plug in the lower bound, so we're going to have 3, and we're going to square that quantity. All right, so we'll take the derivative at the end when we finish, but let's see what we have here. When you take 5x and square 5x, you got to square the 5 and square the x. You get 25x squared. Take 3 and square it, and you get 9. All right, and now what is the derivative? Finally, we can take the derivative of our answer. The derivative here, when you take the derivative of 25x squared, you get 50x, okay? Minus when you take the derivative of a constant, you get 0. So our answer is 50 times x, okay? So here is our answer, all right? And just again, to recap, working from the inside to the outside. So we're going to do the integration first, then the fundamental theorem in calculus, plug in the upper bound minus plug in the lower bound, and then simplify our answer. When all is done and over with here, take the derivative at the end. Okay, so we save the derivative working from the inside to the outside. We have 50 times x for our answer. All right, so now there is a shortcut. There is a shortcut rule that you can use to achieve and get this answer. So let's take a look at this shortcut with this example. Okay, so what is our example here? Well, it's the derivative. Our integral lower bound is 3 and upper bound is 5x. Okay, and we have 2t dt. Okay, so we're going to use the same exact example, but let's take a look at how this formula works. Okay, how does this formula work? Well, the derivative of the integral, those operations will cancel out. So we're going to keep whatever this function here, we're keeping it, we're going to use it. Okay, and do you see what it tells us to do? Okay, because you know our bounds, well, it could be a number, but we're using u and v to represent the bound because they're functions. Okay, so the derivative of the integral operations cancel out. We're going to retain our function here. What are we going to do with our function? We're going to take whatever the upper bound is and plug it in. Okay, so whatever the function is here, you plug in the upper bound, and that gets multiplied by the derivative of the upper bound, and then you're going to subtract from that. You're going to take the lower bound, and just substitute it in, and then you're going to multiply that by the derivative of the lower bound. Okay, so there's your rule. All right, tells us exactly what to do. So now let's go and do it with this example. Okay, what does our rule say? So the derivative of the integral expression cancels out. The 2t, the integrand right here, the 2t, this is what we're going to use. Okay, so we're going to use this exact, that's what the function is, and that's what we're going to use to compute our answer. So what are we going to do with this expression? We're going to take the upper bound and plug it in. Okay, so you take the upper bound and plug it in. So you're going to have 2 times, well, take the t and substitute 5x in. Okay, and that gets multiplied by the derivative of the upper bound, and the derivative of the upper bound is 5. Okay, then you subtract from that. This is how we're retaining the fundamental theory of calculus, right? Plug in the upper bound times the derivative of the upper bound. Okay, subtract from that, we're going to plug in the lower bound. So plug in the lower bound, so you have 2 times plug in the lower bound for x, that's 3, and that gets multiplied by the derivative of the lower bound, which is 0. All right, see how this rule works here? Okay, so the derivative of the integral expression will cancel. You're going to take this 2t right here, that's the function we're going to use. You're going to take that expression right there, you're going to plug in the upper bound, that gets multiplied by the derivative of the upper bound, all right? Then you're going to subtract from that, you're going to plug in the lower bound to that expression, that gets multiplied by the derivative of the lower bound, okay? Let's compute and see what we have. 2 times 5 is 10, 10 times 5 is 50, so there's our 50x, and then we're taking away from that 0, so your answer is 50x, okay? Which is exactly what we got here. So just so you can see that this formula does work, okay? So it does, really it does work. So, and this is what you're going to need to use. Sometimes they give you an expression here that if we can't integrate it by hand, okay, so sometimes this method here is not possible. If they give you something that cannot be integrated by hand, then you will have to use this rule to achieve your answer, okay? So whether you use in this case, okay, so whether you use the long method or our little shortcut, you're going to get 50x for your answer, okay? Okay, so hopefully this gives you a little bit of insight onto this second fundamental theorem in calculus. I hope this helps. Thank you again for watching.